Alright, the next thing I want to talk about is how to find the appropriate critical F value. There is an F distribution in Appendix H in your book. However, most of the values you'll need to find, you'll actually have to look up online. So first thing you want to do is just Google critical F value calculator. First thing that comes up right there, I'm sure that one will work, free critical F value calculator. And then whenever we're figuring out F values or critical F values, it's always based on D1 or degrees of freedom 1 and D2 or degrees of freedom 2, and then your significance level. So the first one, just for example, asks us, find the critical F value when D1 is 9 and D2 is 24 and the significance level is 0.05. So just type those in and calculate. And that would have a critical F value of 2.300. Alright, the next example here is from chapter 11.2. And now 11.2 is on hypothesis testing when there's two different population variances. So let's see, we're going to check out 11.2.19, which is number 4 from your 15th homework assignment. And the problem reads, given the accompanying null and alternative hypotheses and sample information, complete parts A through B, which is basically just a hypothesis test. So we're given the null and alternative hypothesis here. The null hypothesis is that the population variance from sample or from population 1 is less than or equal to the population variance from population 2. And then of course our alternative hypothesis is just that the population variance from population 1 is greater than the population variance from population 2. Again, these subnotes just denote whether they're from population 1 or 2, 1 or 2, right? And then we're told sample 1 is 15, well sample size 1 is 15, and the sample variance from sample 1 is 1475. The sample variance from sample number 2 is 1193. Alright, so of course since we're doing the hypothesis testing, we're just going to follow those same 5 steps. Step number 1, identify the null and alternative hypotheses. These are already given to us. Step number 2, well, we're told to test the hypothesis at the 0.025 or 2.5% significance level. So that takes us to step number 3. Calculate the critical values. Now, when we're testing two population variances, now instead of having a z critical value, a t critical value, or even a chi-squared critical value, we're going to have an f critical value. The f critical values are from Appendix H, but most of the time you'll probably just need to look up f critical values online, and there's a video of me doing that too. Alright, so our f critical value, well let's see, based on our null and alternative hypotheses, we're going to have a right tail test. So because we're testing this at the 0.025 significance level, that means we want to figure out the critical value so that 2.5% of the areas to the right or 97.5% of the areas to the left. So once again, those critical values now on this F distribution are based on 2 degrees of freedom, or D1 and D2. D1 is just the degrees of freedom from sample 1. So in this case, since sample size 1 is 15, D1 is going to be 14. Since sample size 2 is 20, our D2 is going to be 19. So at the 2.5% significance level, or 0.0025 significance level, and D1 of 14, D2 of 19, I come up with an F critical value of 2.6469. So of course, our rejection region then will be anything greater than that. So we're going to reject the null hypothesis and accept the alternative if we get an F test statistic that is greater than 2.6469. Alright, step number 4, calculate the test statistic. And And once again, now we're going to have an F-test statistic, and that's super easy. It's just the sample variance from sample 1 divided by sample variance from sample 2. So that's just going to be 1475 divided by 1193. And that comes out to be 1.2.36. Or sorry, not 1.2.36, 1.236. There's our F-test statistic right there. And then, of course, if 2.64 is there, 1.12 should be somewhere about right there. So clearly that's not in the rejection region, or it's not greater than 2.6469. So because it's not in the rejection region, we're going to fail to reject the null hypothesis. And part A was just if the calculated test statistic F was greater than 2.6469, we would reject the null. Otherwise, we don't reject the null hypothesis or fail to reject it. And then part B was determine the test statistic. Of course, ours was 1.236. And then based on our F-test statistic and then our critical value, of course, we're going to fail to reject the null hypothesis.